Hey everybody, this is 1.1 Classifying Polynomials and Distributing. Alright, so first off we're going to start with a little vocab. We've talked about equations before, maybe like linear equations, where we've had like mx plus b, and like that is a polynomial, but perhaps we haven't talked about it in this way. So anyways, a polynomial has different parts. It has a coefficient. So a coefficient is any number that's in front of a variable. So if we look at this example, we have three coefficients. We have 2, that comes from here. We have a -4, that's from here. And then we also have a 1. Typically we don't write that when we have an expression, but there is still like an invisible 1, so 1x to the third. All right, next we have is the constant. So it's a number on its own. So if we look at this example, sorry, it's kind of making you sick probably, our constant would be the -9. Okay, and make sure that when we identify these terms, this vocab, or if I ask you to find the constants or the coefficients, the signs go with it. So here we do have like this -4, or here we have this -9. So the signs go with the number. Okay? All right, next we have the number of terms. So if you would add that on there, we'll talk about what a term is, but what we're asking for more on your homework and test will be the number of terms. How many terms are there? So a term includes the numbers and or variables. So you could have just a variable, you could just have a number, or you could have the combination of a number and a variable. Okay, and they're separated by pluses or minuses. So if we go back to this example, this would be one term, this would be another term, this would be another term, and this would be another term. So here we have 4 terms. So here we'll just say we have 4 terms. Or you could just say 4. Okay, so the number of terms is 4. Okay, and why we want to know that? Well, we will find out in just a minute. Next we have degree. So degree is the highest exponent. So if we look at this example, what is the highest exponent? Again, exponents are things like to the 4th or to the 3rd. This would be like an exponent of 1. So what is the highest? Well, the highest exponent is a 4. So the degree of this polynomial has 4, and a power of 4. Okay? All right. Next, polynomials come in different forms and can be classified by the number of terms in a polynomial and by the degree of the polynomial. So let's talk about a little bit more vocab. So if we're classifying a polynomial by terms, like how many terms there are, if there's one term, it's called a monomial. Think of like monocle, like if you have like one little glass on your eye or whatever it's called, or like monopoly. Okay, so we're kind of using like these Latin roots. So mono meaning one, okay, not to be confused with like uni, which also kind of means one. So monomial meaning one. So if we have mono means one, what do you think 2 is? So like a bicycle, or like, I don't know, anything that have like bi, okay, that means 2. So here we have like binomial, okay, so bi meaning 2. And then 3 terms, what do you guess? If we have mono, bi, tri, so tri like tricycle, trinomial. Okay? So mono, bi, tri for the number of terms. If we have more than 4 terms, we'll just say a polynomial with 4 terms, or 5 terms, or 6 terms. So here we could say like with that number of terms. Polynomial with 5 terms, okay? All right, next we can classify by degree. So again, we're talking about degree, that's your highest exponent. It doesn't exponent, sorry. It doesn't matter how many terms there are. So for example, with 1 degree, we call it it's linear. Took me a second, okay? So you've talked about linears before, like when you do things like mx plus b. So we have an exponent with a degree of 1. Another example you could do like with a number like 2x plus 5. Okay, so this is just examples. If we have a degree of 2, well, that's going to look like something, for our example, we have to have like an x squared. Okay, a power of 2 is our highest exponent. So something like that could be, that's called a quadratic. All right, so an example could be x squared plus x, or 3x squared plus x plus 7, okay? So the most you could ever have would be 3 terms, right? Because we don't have anything after the constant. Okay, and then degree of 3, that is called a cubic, all right? And an example of that could be something like 4x to the 3rd plus 2, or x to the 3rd plus 2x squared plus x plus 1, or something like that. So there's lots of different choices for that. As long as the highest degree is 3, then it is a cubic. And if we have a degree that's more than 4, then we will say like a nth, n meaning any number, so like an nth degree polynomial. So like if you had an example that would be like x to the 5th plus 2, that would be called a 5th degree polynomial. Okay? All right, so being able to classify those, that's just going to take a little practice, memorizing, do some examples. So look for that on the homework and tests. All right, in order to classify a polynomial, the polynomial must be in standard form. So standard form means highest exponents to the smallest. So something like where we would have all of these examples that I've given you, those are all in standard form. The highest exponents first, like here we have a 3, and then the next exponent's a 2, and then an exponent of 1, and then here we have our constant. All right, so always, whenever you do a problem, it should always be in standard form. And we won't be doing that right now, but in the future you will. All right, so here we're just going to identify this information for each polynomial, and then classify. So classify are like these things, classified by the number of terms and by degree. All right, we're going to do the first 2 together, and then I'd ask you to please pause and do C and D. All right, so list the coefficients. Again, coefficients are the numbers in front of a variable. So we have -10. The constant here is a -1. It doesn't have a variable with it. And then number of terms, we have 2 terms, 1, 2. Okay. And then the degree, again, if we have a variable and it doesn't have, if you can't see an exponent, it's always going to be a 1. So a degree of 1. And then we want to classify. So classify by terms is going to be, well, how many terms? There's 2 terms. And again, we have mono, bi, tri, so we have a binomial. And by degree, the highest degree is 1, and that is called linear. All right, so here's another example. If you want, you can pause and give this a try. Coefficients, we have -2 and another -2. So if you have the same thing again, just write it again so we can keep track of how many things we've got. All right, and then we have a constant of 7. Number of terms, we have 3, so that's 1, 2, 3. And then the degree, the highest exponent is 2. and then we will classify. So by terms, we will call it, we have 3 terms, so that's mono by tri, so it's a trinomial. And then by degree, its highest exponent is a 2, so that is called a quadratic. And we will talk a lot about quadratics this year. So in the past you've done linear, this year we're doing quadratics, and then when you get to Sec 3, they'll be like cubics and more than that. So, all right, pause and see if you can do C and D by yourself. All right, hopefully you gave that a try. So coefficients, -6, -8, 5, constant of -10, number of terms is 4, degree is a 5. And then classification by terms, we call it a polynomial with 4 terms. And by degree, it would be a 5th degree polynomial. Okay? And then here, hopefully I gave this one, our coefficient here would be a -1. So again, if we can't see the number in front of a variable, it's always a 1. And then we have no constant. Number of terms is 1, degree is 3. So we would call this, by terms, we would call this a monomial. And then by degree, we would call it a cubic. Sometimes we combine those together and we call this a cubic monomial. Or like up here, we could have called it a quadratic trinomial or a linear binomial. Okay? But I think they'll be separated. All right. Okay. Next. So that's a big thing that's kind of new. I think perhaps you have talked about combining like, I'm pretty sure you've talked about combining like terms. I'm going to ask you to simplify expressions a lot, and to do that we will combine like terms. Like terms means that they have the same variable and the same exponent. So let's start here. I would always look for your highest exponent. So here we have our 2's, and here's another 2. So they have the same variable. They both have x's, and they have the same exponent of 2, their degree of 2. So that means we can combine those. So you add or subtract just like you would as if there were no variables there. So 5 minus 3, well that's 2. So 2x squareds. And how many x's do we have? Well, here we have our x's. We have 2 x's, and we're going to take away 6 x's. So we'd end up getting -4 x's. And then finally, we have our constant by itself, and that's okay. We'll just write 13. And then this already puts you in standard form. So again, please always write your equation in standard form. So like this, C, that would not be in standard form, and you would lose points for that. Okay? Here's another example. I'll do B, and then pause and see if you can do C and D. So highest first. Sometimes if you do like the same shape or lines underneath, that will make sure that you don't miss any. So we only have one k to the 4th. Then we can look for our k's to the 3rd. Looks like we only have one of those. So minus 4k to the 3rd. And then we have our x squareds. Well, we don't have any of those. And then we have our x's. So maybe I'll do triangles on those. And that's 12 plus 5 plus 1. So that would end up giving us, what, 18? So plus 18k. And it's in standard form, highest exponents to the lowest, and we got it. All right, pause and see if you can get this one. I'm just going to write down the answer. Okay. And remember that the number, like the sign, like the negative, goes with, it's part of your coefficient, so you can't separate that, okay? And then this one, if you did that already, this goes first. There's nothing to combine here, it's just putting it into standard form. So -8 n to the 3rd and then we have plus 2n squared plus 15n, and then plus 7. Okay, so sometimes you don't even need to combine anything, it's just you need to put it in order. All right, last but not least, it looks like we're talking about the distributive property. You have done this before as well. So remember to multiply the number outside of the parenthesis to everything that's inside the parenthesis, including the negative, if there is one. So here, and maybe I should put this here, and it's probably in the homework too, put it in standard form. Okay, so to distribute, we would multiply the 5 and the 1, would multiply the 5 and the negative 2, or 4, sorry, that would give us negative 20. And then we need to make sure it's in standard form. So we need to put this 5 over here. So negative 20x plus 5. All right, here is another example where we have a negative. So we need to make sure we multiply negative 2, not just the 2, but the negative 2 by everything. So that gives us negative 6x. And then negative 2 times negative 2 will give us a positive 4. So just remember, negative times a negative is a positive. Here's another example. Just make sure you follow PEMDAS. So we always do our multiplication first. So we wouldn't want to subtract that first. Multiplication first. Distribute. Use the distributive property. So we'd have 4 already. And then negative 2 times 5 is negative 10a. And then a negative 4. Then we can combine like terms. So that's a like term, that's a like term. Looks like they cancel out, and we end up just getting negative 10a. All right, so I hope that makes sense. If you want, you can do D as well, and E. I think I will just write, if I can find that. Oops, sorry, give me 1 sec. I will just write those answers down if you are interested in doing the problem. All right, there it is. So here we have, this should give us negative 6p plus 18. If I did that right, unless I changed that. Oh, what the heck, why don't we just do it? I think I might have changed the problem. So that gives us 20 and 16k plus k. So that gives us 17k plus 20. And then here, 15 minus 35x. And then negative times 1 gives you a negative 1. And negative times negative 6 gives us a positive 6x. And then, oh yeah, that was totally different. And then combine like terms. So here's our x's. Looks like we get 29x and plus 14. Okay, kind of went quick on that, but if I made a mistake, let me know. I can fix that. All right, so that is it. Please go to your homework and complete that homework. Again, it's due the following class period. And if you look on Canvas, it will also have the due date there too. All right, we'll see you later. Bye.